Doubly linked list is a data structure in which it contains node and connections. Every single node is connected to two nodes, its next node and its previous node. This is how we create a node. Just pass the value its previous and next node. This is to print the node. Yeah, and this is to initialize the doubly linked list. We create a head and tail set to default values. In case of head, set previous and next to null. In case of tail, set the previous to head and next to null, and then connect the next of head to the tail. So that way, tail comes after head, and head comes before tail. This function returns the first node. This function returns the last node, and after this returns the node after the next node that we passed as parameter. Firstly, it's going to check for if the node is null and if the next node is null, and return exceptions accordingly. Add last uses add between, so I'm going to go through add between first. Here we pass in value the previous and the next node, and it will create a new node and insert that node between the previous and the next node. That way, so we create a node, set the previous node's next node to the one we want to add, and next node's previous node to the one we want to add. Increase the count interval and just return that node. Find. It creates a node and set its to head.next, and it's gonna run until we reach the tail, and for every iteration we'll check if the value equals the value that we passed. If that's true, we'll return the node, otherwise we'll return null. ToString, it deals with printing out the whole doubly linked list. Before, this is similar to after, but it returns the node before of what we have passed. Same thing, we're going to check for if node is equal to null or the previous node is equal to null, and return throw exceptions accordingly. Add first uses add between, and this just adds node between head and the next node to head. So this is used to add nodes in the beginning of the doubly linked list, in the front of the doubly linked list. Add before, it's like add after, but in case of after, we're gonna return before the node. So we pass in the node and a value, and we create that node and find if it's valid and the value is not null, and before is not null, the before node is not null, and then we're gonna use add between to insert the node before the one we passed. Add after, again, like add before, but in case of we're just gonna add after the node that which has been passed using add between. Clear. Before going to clear, I'm gonna go through remove first. Sorry, remove and then remove first. In this case, we pass in a node and we want to remove that node from a list. This is where the removing process happens. This is to check if the node is null or the value is null. So throw exceptions accordingly. We create a node and we check, and we set the previous node's next node to the current node's next node. So it just skips the node that we're gonna remove. It's just relinking the previous and the next node to the one we want to remove. In case we'll have to do it 4 times, as if we imagine the node, it will have like 4 connections, one goes to back and the other goes from the previous node to that node, and in the same case from the node to the next node and the next node to the current node. So we have to remove all these connections accordingly. Firstly, this connection from the previous one to the current one, we can read out to the next one. And similarly, the connection between the next and the current, we can change it to the previous one. And the connection which are left, we just set it to null and decrease the count. Remove first, it removes the first element. It just sets the head and heads to head dot next, and head dot previous equal to null just removes the first one. And remove last, similarly, it just moves the tail one time and just removes the previous one. And now for clear, there's many approaches to use clear. In this case, what I did is that I'm iterating through the list and calling remove on a node after setting every node. Sorry, firstly, I'm gonna set the node to head, and then I'm going to set the count. Check run this until the count rate becomes 0, and I'm gonna set the node to head dot next, and I'm gonna remove that node, and this will run again and again, and just keep setting the node to head dot next and removing that node. I could also it can be also be done by calling remove first, so it's gonna call just after every iteration just keeps removing the first node, or we can start it from the last and just keep removing one at a time. So a lot of ways to do it, and after that I'm gonna reinitialize everything so that everything has connections, appropriate connections, and that's it.